Hey everyone, welcome back to the channel. Today we are building something really exciting, a decentralized reputation system using RAS or Rootstock Attestation Service. By the end of this tutorial, you'll understand how to create tamper-proof on-chain proofs that can basically revolutionize how we verify information in the world right now. But before diving in, let me ask you something. How do you prove your reputation in today's world? Maybe you have a LinkedIn profile, or in Web3 we have Twitter profiles, or you might have some reviews on freelancing websites such as Upwork or Freelancer, or ratings on an eBay. But here's the issue. All of this data is controlled by centralized companies. They can change it, delete it, or even ban your account entirely. It happens almost many times with us. What if there was a way to have permanent, verifiable proofs that no one can tamper with or take away with you? That's where Rootstock Attestation Services comes in. RAS is built on top of EAS. EAS is basically Ethereum Attestation Services, which is like a global notary system on top of the blockchain. But instead of running it on the Ethereum instance, RAS runs on Rootstock, which means you get the security of Bitcoin's network, along with smart contract capabilities of the Ethereum, and lastly, lower transaction costs. Think of RAS like a digital stamp of approval that's permanent, verifiable, and basically trustless. Now, let me give you some real world examples for this. First of all, think of it as you are a freelancer. Every time you complete a project, your client can issue an attestation, basically saying that this person delivered the work on time and it was the quality work. This proof stays with you forever across all of the platforms. Let's take another example, such as our code contributions. In our tutorial today, we are building a reputation score system. Think of it as a GitHub stars, but on-chain and verifiable. You can prove your contributions and reputations, but actually without relying on any platform. That's too powerful, right? Okay guys, so now let's just go over to our final version of the front end that we are going to build in this tutorial so that you can get to the functions that we are going to make. So first of all, we have a basic connect wallet button that just connect with our MetaMask wallet. And then we have our dashboard right here. We have three functions, which are basically issue attestation, first of all, a schema setup, and then lastly we have our verify attestation. First, user will basically set up a schema. Let's just go ahead and check out its functionality. Let's describe its schema description. For this testing purposes, let's say it as roboto, and instead of score, let's do it scorer, and hit confirm, and our schema setup will be defined. It has the description of the schema name, which is roboto, and our schema string, that will be the data type scorer. And this attestation will be revocable, which basically defines that we can in future basically revoke this attestation. Okay, so as you can see, our schema status is successfully confirmed. We can head over to RS Explorer to check it out, or we can just copy this schema UID right from here. And now we can go to our issue attestation function. This function will basically issue those attestations on that particular schema. For it, we need to paste the copied schema UID. And here is some sample data that can easily go through. Hit the recipient address into it. This is my the wallet's address. I'll just paste it. And we can just hit issue attestation and confirm the transaction. And we'll just wait until the transaction is successfully minted. Okay guys, so after waiting for a long time, as you can see, our transaction status has been successfully confirmed. So what we can do is we can just copy this attestation UID, or we can also go to the Rootstock TextNet Explorer and can just directly go to our verify attestation function till it loads. We can just paste the UID which we copied earlier, and here we can see our status as well as when we issued our attestation, what is the schema definition, the recipient, the attester. Okay, all of the data is visible here. So from this UID, we can easily find out the attestation detail and verify our attestation. This is basically retrieve and confirm attestation from the data from Rootstock testing. Okay guys, so that's how we can verify attestations. Now we can move forward. And that's what the whole of our front end is doing. Okay, we have a pretty decent, clean and simple UI and dashboard that basically, does three works. First of all, we have set up the schema, thereafter issue the attestation, and then we have function to verify it. That's brilliant, right? On this system, we can define a reputation score, credible scores, and everything in order to, build trustless layers and making it verifiable and credible. Okay guys, so before writing even a single line of code, let us deep dive into the architecture of our Rootstock schema structure along with the resolver and the revocable parameter, whether it will be revocable in the future or not. And basically after that, it returns us the schema UID, which we can put into our Ethereum attestation service contract in order to, attest that schema with our different wallet. Okay. And along with it, we can also mark it as revoke if it has been revoked or not. And we'll have the permanent storage of that attestation. In the front end, we basically have just three components. First is schema, issue, and verify, which basically connects with those contracts, and schema basically calls the schema a register a function on the schema contract, and issue a component calls the attest function on the EAS contract. And lastly, we just verify them by queuing them out. So that's basically how we are gonna do this functionality in our dApp. We're gonna use Ethos library to directly integrate with the smart contracts. Okay, so without wasting any further time, let's deep dive and delve into the code mode. Okay guys, so in order to code, we will have to go to the GitHub repository of our code base. So here on github.com/rhythmrm02, that's my GitHub handle. Okay, that's my GitHub handle. In it, the basic RAS dApp directory, we have all the initial branch code in the base branch, which is right now the default branch. Okay, so what we can do is we can just copy the link and go to our terminal. And let's just go to the developer folder in the blockchain in the Rootstock file and create a new directory named as RAS. And inside of it, let's just clone this repo, okay, by using git clone and command v and into this directory. And we need to specify the branch as base. And once cloned, we can check it out. Yes, it is successfully cloned. And now what we need to do is, first of all, install all of the dependencies needed for styling and template and wallet setup of our file in this base directly. Basically, our wallet is already set up. So once our dependencies are installed, we can just open it by cursor or respective IDE. So yeah, this is our basic code, which we are gonna, evolve for the whole dApp. First of all, we have our page.tsx file. This is very basic front end. Thereafter, we have our connect wallet button, in which we are just basically connecting it to the Rootstock testnet. We have our use wallet.tsx context, which basically specifies all of the configuration and wallet functions. It basically uses several use state snippets to get provider address and signer from our MetaMask wallet, and justifies that we have also the functionality to switch the network if the network is not Rootstock testnet. So yeah, that's basically what it is doing. If we go to our terminal, and in here, when I run npm run dev, you can see it successfully starts on localhost 3000 port. So we can just go ahead and check it out. Okay, so as you can see, and on our localhost 3000 port, we have our simple, clean UI and UX. So we can just hit connect wallet button. It just connects us to our wallet on the RSK testnet, as you can see. And we have three buttons, one for issue attestation, another one for schema setup and verify attestation, as shown earlier. So we are good to go. So I'll go to my cursor. Now we just need to edit these three components in order to, get the functionality set. Okay, right now we just have the sample hard-coded things in here. So we will start by, editing our schema modal.tsx. So let me just go ahead and paste out the code, then we can go along here. So first of all, we are basically importing the schema registry natively from the Ethereum Attestation Service, that's EAS SDK, and thereafter we are using the useWallet instance from our useWallet hook and bringing the ethos and signer, which is basically very essential in order to interact with the smart contract. Okay, thereafter we are defining few interfaces for our TypeScript. Okay, so this basically is our schema registry address, which is very important to create our schema. This will be our resolver address. It's basically currently set to 0 address. Okay. Now we are just getting the signer and wallet address. That's too simple. Thereafter, we are setting the schema name, which we have given in the form of the div. That's basically an input tag. Thereafter, we have our fields, which we are also setting the schema fields. Thereafter, we are setting the revocable function. Now, the main thing comes in the Web3 functionality. That is started from right here, the handle deploy function. Okay, so what this function does is, it first of all basically checks that signer and is ready to deploy states true. Thereafter, it go ahead and set the generate schema string. If schema is wrong or formatted wrongfully, it sets it correctly. Thereafter, we are basically trying to create an instance of a schema registry contract with a schema registry contract address. We are basically connecting to it with our signer, and thereafter this is the main functionality. We are just calling out the function schema registry.register from our contract and passing the required parameters that are needed in order to create the schema. Thereafter, we are just getting the transaction hash and the schema UID we are getting from the receipt of the transaction. Okay, once we have got the schema UID, we are setting it up in the variable and showing it onto the screen. That's pretty simple, and that's what we are doing in this piece of frontend. That is too cool, right? Now though we have made our schema modal, let's move further to our issue modal. Now this is basically our issue modal component, which is already hard-coded, as you can see. Now we will paste out our dynamic code, which is functional. Here also we are using the Ethereum Attestation Service ESSDK that is deployed on top of Rootstock testnet, from which we are basically making everything functional. Okay, so here we are just getting the wallet state and then defining the ES contract address. This is the main contract which will basically be used in order to call the attest function and attest things with the schema. Now we are also setting a default schema UID. In any case we just want test, we can just hit the attest button and check it out. Thereafter we are setting out our issue modal function and simply getting the signer and address and all those stuff which we got earlier from input tags and form. And then we are just setting out the is ready to attest constant. Now this is our main function, the Web3 function, which is handle attest. This function basically tries to make the instance of EAS contract using the contract address, signer, and ABI. After that, what it does, it basically creates a new schema encoder, which basically prepares the data to be passed in the attester. Thereafter we are declaring score value, which passes the int with score and data, and thereafter we are just putting a check that if the score value is somewhat not formatted, it should be invalid score value and must be 0 to 100. Okay, these are the terms we are setting. Thereafter, we are just calling the transaction using await statement to make asynchronous call, and we are just calling the attest function, the write table function on top of EAS contract, and passing the data which we formatted earlier. First of all, we need to pass a schema UID in order to attest this attestation to that schema. Thereafter, we have in the data set, we have the recipient, the expiration time, is it revocable, and the data which we encoded earlier. Okay, nextly, we have the transaction hash, and once we got the transaction hash, thereafter we can, get the attestation UID from the receipt of the transaction. Now, once we got the attestation UID, we have successfully, achieved our aim, and we just, showcase that attestation UID in order the user wants to verify that UID with our verify modal function. So they can, once shown in the UI, they can also explore, and on the RSK Explorer, we have put the link of it. Okay, our frontend is pretty simple and pretty straightforward. If you know Next.js, you can easily configure it by yourselves. Okay, so we are finally done with our main functionalities of issue modal and schema modal. Now you guys know how you can basically, set up your own schema records on top of ARIAS with Rootstock testnet, and also, issue attestations on the basis of it. Okay, now lastly we have a basic verify modal set, which basically verifies that these attestations have successfully gone through, checks upon their status and gets the live info of it. So let's just go ahead and explore its functions. Okay, so here's our code, and in this function, we are basically importing a lot of things from ESSDK, as we are, not directly using GraphQL, so we are just using various functionalities in order to verify it. So we had to, format data in a much complex manner. But if you want, we can just directly use GraphQL in order to, just fetch the query, but we need to have our own local indexer of RSK testnet on it. But you can just check out the docs of RSK, RAS, and make it by yourselves. It's pretty straightforward. Okay, so first of all, in this, we are importing the EAS schema encoder, attestation, zero address, and schema registry from the EAS SDK. Thereafter, we are using the use wallet state and basically browser provider and ethers for the wallet state. for the interaction to smart contracts and calling. Okay, so now we are stating both contract addresses. Thereafter, we are defining few interfaces of attestation results, verify modal props, and thereafter we are defining a few helper functions in order to format the address, get the safe address of the wallet, and format the timestamp in a correct manner to display the value. Basically, these are the functions to format and organize data in a clear and clean manner. Okay, thereafter we have the extract schema string function. The schema we are getting from the our verify function is in a unstructured manner. In order to showcase it to our front end, we basically need to do the structuring of the data, which we are doing it here. We are defining a new candidate string array, and using for loop we are putting out elements from that schema record to basically this candidate strings. Okay, that's what we are doing. We are basically organizing the data in a good manner. Thereafter, we have the verify modal function, which is basically main function. In here, as usual, we are basically importing our wallet state from use wallet hook. Thereafter, we have our search input and set search input, use state snippets, attestation snippets. Okay, here we are, as you can see, decoding the attestation. We are passing attestation and provider as a parameter and trying to connect with the schema registry contract, passing the provider, of course. And thereafter we are setting up a schema record and putting the schema string into it and expecting that schema record. And basically for console for debugging purposes, we have also used the console dot debug statements to print out the schema string and stuff. Thereafter we have the decoded data, which records the string and the status of attestation result. Is it basically valid or invalid? We have the revocation time of the attestation, when it's going to be expired, when the attestation is issued on. We are basically formatting that timestamp and returning that data in a particular order. Thereafter, we have the handle search constant function, which basically passes a query to the search input, and which basically makes a query and passes the search input.trim function to basically trim that and organize it. Thereafter, we are just declaring the label to do so, until it fetches the ES contract and gets the attestation with that UID which we got earlier, and we are declaring a snapshot constant here, which basically passes the UID of attestation, schema, recipient, attester, decoded data, and all of those data. Thereafter, for formatting it and showcasing it to the front end, it again try to decode it. And we also have declared a fallback function. If anything goes wrong, it switches to this formation of the data. Okay, so that's what basically is happening. And at last, if everything works or not, or setting the result. Okay, so at last we are setting the results with our constant fallback so that everything works very smoothly. Thereafter, we have basic front end, which is basic HTML with Tailwind CSS configurations and styles. Here, as you can see, we have the handle form e.target.value, which is basically providing the value of our UID to our input tags. Thereafter, we have the output variables, which we are getting from result, which we defined earlier in our object, of course. Okay, so that's basically what it is doing. And at last, we are also giving a link in order to redirect user to basically RSK testnet. And if there aren't any results, or the array of results is basically 0, then we are just throwing out that no attestations found for the given query. That's pretty straightforward, right? In order to capture the data, we need to handle it very safely in this case. But if we want to display it unstructured way, we can also do that. It's up to you whichever method you prefer. Okay, so let me just save these files. And as you had seen in the demo, all of the functions already work successfully, and our front end is now functionable. We can, basically issue attestations on our previous. We can basically issue attestations. We can basically, set up our new schemas and verify them as we would like. Okay, let me just show you a quick example of it. Yep, so as you can see, our attestation is successfully issued. I can just, copy its address, and in the verify attestation, I can just chip it in. And as you can see, our, verify attestation function throws out successfully raw data and all of the details. So that's what our whole tab is doing. Okay, guys, so that was it. Now let's just quickly recap what we have gone through in this whole session and what we basically accomplished today. So first of all, we got to interact with those smart contracts of attestation registry and basically schema setup. Thereafter, we created custom attestation schemas for loan repayment verifications. We, built a complete Next.js TypeScript frontend with wallet integration. We implemented the attestation issuance. We added verification functionality so anyone can validate attestations on chain. We basically designed a dashboard in order to people calculating the attestations, verifying them, issuing them, and creating new custom scheme. Now, this isn't just a cool demo. The Rootstock Attestation Service opens up incredible possibilities. You can build basically a DeFi lending platform with it, which basically, gives loans to undercollateralized assets for those people who don't have much collaterals. It can give loans to them based on the reputation. It can give education credentials, tamper-proof certificates, diplomas using the attestations of professors, basically to generate more identity systems for privacy preserving KYC and compliance. There is a whole bunch of new things you can make using these attestations. So what makes this special is Rootstock's unique position in the blockchain ecosystem right now. Bitcoin level security with smart contracts functionality. It basically provides low transaction cost and much faster speed than Ethereum mainnet. It is also EVM compatible. This is all EVM tools, which makes it very, very developer friendly. And it is, merge mined with Bitcoin, leveraging the most secure blockchain in the whole globe. Okay, so what's next for you is you can explore the ARIAS documentation. You can basically customize this tab and, integrate the reputation system in it, credible scores in it, and whatever you like, you can be innovative with it, creative with it, deploy it to basically mainnet, and even join the community of Rootstock Discord, which developer can, ask questions with developers, you can, solve bugs and get new ideas from that. So guys, all of the code of this tutorial is available on the GitHub. You can just, hop on to the repository by the link given in the description. There's the deployment guide and step-by-step instructions in the GitHub README. Okay, so that is all, guys. I'd love to, see you building crazy innovative ideas with Rootstock Attestation Service. See ya until next time. Thanks for watching.